All right, so here we have the antiderivative of ln of x to the fourth over x. Well, I think what's inside here, we have to the fourth. So if I take and let u equal ln of x, that's the biggest piece. And so I'm going to use that. And so what's the derivative of u? Well, if I take the derivative of that, that's just going to be 1 over x and then dx. Okay, well, guess what? 1 over x dx is there, and that becomes u to the fourth. So now I have u to the fourth du. That's pretty easy. And in derivative, that's u to the fifth over 5 plus c. Now my u is ln of x, so it's going to be ln of x to the fifth over 5 plus c. Okay. Well, there's not much difference in this one here. The only thing we have is we have a 5 we have to pull out. And so we're going to say again, u equals ln of x, du equals 1 over x dx. And so now we're going to have the integral of 5 u to the fourth du. Okay, so that's going to be 5u to the fifth over 5 and then plus c. Well, those cancel, so we really just have ln of x to the fifth plus c. So notice that one, we got rid of the 5 when we plugged that 5 up there. So that's kind of what we should expect because we have 5 times this one to get to here. Well, 5 times that is this. Okay, so that's our solution to that one. So that was a quick, easy one to switch over to. All right, what about this one? Again, inside function, I'm going to choose that piece. I'm going to say u equals x squared plus 1, and du equals, well, that's going to be 2x, and then dx. All right, well, I've got an x dx, but I don't have a 2. So what I'm going to have to do is I'm going to say, well, I'm going to have to multiply what this is by 2 here. But if I multiply by 2 here, that's going to be double what I need. So I'm going to also have to take 1/2 of that. So I'm going to have 1/2 of, now I have 2x dx, well, that's du, and then I have ln of u du. Okay, so that's what I have to do. And I have to remember to put that 1/2 there because I had to multiply by 2 to get this 2x dx, which is what I needed for du. And so to get rid of that factor of 2, I have to take the reciprocal of it. So if I multiply by 3 here, I have to take it, or 1/3 here, I'd have to multiply by 3 here. And so all is just reciprocals of whatever you have to multiply by. So now the antiderivative of ln of u, well, that's the complex one. That's the u ln of u minus u, and then I have plus c. Now u's got to be replaced, so that's going to be 1/2 of, now that's going to be x squared plus 1, and I need another, let's maybe put a bracket there, and then that's going to be ln of x squared plus 1 minus x squared plus 1, and in bracket, and then plus c. Okay. Now I could also put, this whole thing over 2. That might look better, but at this point in time, I think this would be fine. Again, all we'd have to do is just write this piece in brackets over 2, and that might look a little nicer. All right, how about this one? Well, again, we have inside that ln of x we can take easily the derivative of. So let's let u equal ln of x, du equals 1 over x dx. Well, guess what? With that 1 over x dx, that's this piece, and this is our u. And so it looks like we're going to have the integral of 1 over u squared du. Well, I'm going to say, well, let's change that to u to the negative 2 du, and that's going to be a little easier to work with, okay? Because I'm going to take it up here, and then I know what to do with this. I'm going to say, well, that's going to be u to the what? Negative 1 over negative 1, and then plus c. Well, u to the negative 1 is just 1 over u, and the negative 1, I can put that on top. It doesn't matter where it is, plus c. And now my u is ln of x, so it's going to be a negative 1 over ln of x plus c, and that would be my answer. All right, let's go to the next one. Let's pause and we'll come back to the next one.